Evolution is supposed to reward survival. What helps you survive longer lets you stick around and pass those traits on to the next generation, which makes this animal, the rosy maple moth, difficult to explain. Because bright colours should make you stand out to predators and get you eaten. But somehow, this moth looks like someone painted their first Space Marine, and it's doing perfectly fine. This seems to defy all logic, but it can't be, because you can find these things across half a continent. So let's start digging and find out how. It makes sense for animals to try and blend in with their surroundings to hide them from potential predators. That usually means taking on the shapes and colours of the things around them. Stick insects blend in with the sticks, leaf insects blend in with the leaves, and here in the UK, some moths even change their colour to blend in with their sooty surroundings during the Industrial Revolution. The bright colours of some butterflies make sense, as they spend lots of time collecting nectar from brightly, or at least similarly coloured flowers. Anywhere else, and those same bright colours would make them stand out more to predators. There's quite a bit more to it than that, but for the moment, just keep these images in mind. A bright yellow butterfly is well concealed on a bright yellow flower. This is relevant to us because that explanation doesn't make sense for the bright pink and yellow colours of the rosy maple moth. It doesn't spend time feeding from bright pink and yellow flowers. Like all moths of its family, the giant silk moths, rosy maple moths don't have mouthparts. They cannot eat at all, let alone from flowers. So we'll have to look elsewhere for an explanation. What about signalling? Lots of poisonous and venomous animals have bright colours to warn off other animals from trying to prey on them. Kind of like a big warning sign that says, "Back off, I'm dangerous." And in technical language, we would call that aposematism. Think of poison dart frogs or coral snakes, for example. This can also entail bold patterns and foul odours and tastes, as well as just bright colours. However, there's no good evidence that I could find that rosy maple moths produce any kind of toxic compounds for defense, or that they're poisonous in any way. In fact, they are common prey of some very common predators, things like blue jays and chickadees, and the delightfully named titmouse. At best, their bright colouring might be a sort of mimicry to try and trick their predators into thinking that there's something more dangerous, like the very mammal or bird-eye looking eye spots on some butterflies and other insects, which mimic the appearance of much bigger and more dangerous animals. But again, I couldn't find any actual research to back that idea up firmly. In fact, the only research I could find from the 90s showed that this species of moth was perfectly acceptable prey to common bird predator species. And actually, that aposematism, or mimicry of that, was associated with preferential consumption by those bird species compared to other moths that don't display bright colours. While we're on the subject, it's important to take a moment and acknowledge a limitation of our discussion so far. This might look bright and nonsense to us, but as we've said, the major predators of these animals are birds, who see colour very differently to us. For example, many birds are able to see into the ultraviolet spectrum of light, meaning that they can see patterns that would be entirely invisible to us. So, as I say, that is a limitation of what we've been saying. Just because this looks silly to us, their predators might be seeing something entirely different. However, the finding that birds actually like to eat these moths more than others puts a dampener on that criticism. Even if the birds are processing these colours differently, they're still not working to save the moth from getting eaten. So we're left asking again, if it doesn't work as general camouflage, and it doesn't work to signal sort of poison or mimicry of poison, and in fact might even make the predators more interested, how does this moth get away with being so flamboyant? Strangely, as I mentioned, there's not been much research actually done on these guys, except for how their caterpillars can be pests to some kinds of trees. But maybe that's a clue in itself. These moths lay their eggs on a few different types of tree, but mostly on maple trees. That's where they get their name from. If we look at images of rosy maple moths on maple seed cases, the bright colours suddenly seem so much less absurd, more familiar and sensible. So maybe I was wrong and it was camouflage all along, but that explanation introduces a new problem. Bright colours make sense as camouflage when you spend lots of time around brightly coloured things, like yellow butterflies around yellow flowers. But while the rosy maple caterpillar stays on the maple tree it was laid on, eating the leaves until it eventually forms a cocoon and metamorphoses into the adult moth, that adult moth isn't tied down in the same way. As we already said, they can't eat, so they don't need the maple tree for food in the way that the caterpillar does. They can, and do, go wherever they want, often very conspicuously. Despite that, I still think camouflage is the most likely explanation, but a highly situational camouflage that's only effective during the time that the moth is laying its eggs on maple trees. Whatever costs its visibility or appeal to predators creates, apparently aren't enough to outweigh the advantage that it gets during reproduction. The rosy maple moth hasn't evolved to blend in everywhere, it's evolved to blend in at exactly the right moment, the moment where it most needs protection. Evolution hasn't created a generalist, equally capable of surviving anywhere, but rather a specialist, locked into exploiting a specific niche of its environment for completing its life cycle. And crucially, natural selection doesn't care if this looks ridiculous to us. It only cares if it works in practice. While these conclusions of situational camouflage and maybe, but also possibly not, anti-predator poison mimicry do seem logical, and certainly a very popular take I was finding online as I was researching this video, I couldn't find any actual studies using real and specific data to back those conclusions up thoroughly. So if you out there know of any of those studies, please make sure to let me know. I would be very interested to read them. Insects are a new arrival to this channel, and they are an absolutely dizzying array of biological and ecological diversity to start digging into. So if you like this video and you want me to make more like it in the future, please make sure you say so. Like, comment, ring the bell, all of that stuff. You're all YouTube users, you all know the drill. Anyway, thank you once again for your time, and I hope to see you again soon.